So this is a video of me going over the Unit 10 Section 2 notes over sector area and arc length. First thing we're going to do today is we're going to talk about how we find the variables in this problem. The first thing I notice is that this is a 30, 60, 90 triangle. We know that this is 60 degrees down here because those two angles, D and F, in the triangle DEF, have to add up to be 90. Okay, so then I noticed that this is opposite the right angle here, so that's our hypotenuse. And I know that we have two formulas for this. We have H equals 2S, and we have L equals S radical 3, where H is the hypotenuse, S is the short leg, and L is the long leg. So in this problem, if it tells me that the hypotenuse is 40, then the short leg has to be half of that, so it's 20. Then we can label this to be 20, and once we label that to be 20, we can just plug that into the formula for the long leg. So the long leg is W, so W is equal to 20 times the square root of 3. So we have these two done. Now we have another 30, 60, 90 triangle over here, because again we know this has to be 60 degrees. So we now have the long leg. So we're going to plug the long leg, which is 20, into the formula. When we do that, we're going to end up dividing both sides by the square root of 3, then we'll multiply by the square root of 3 over 3. So that means that this short leg down here is going to be 20 square root of 3 over 3. Now, when we multiply the short leg times 2 to get the hypotenuse, we multiply 2 times 20 square root of 3 over 3. That gives us 40 square root of 3 over 3. That's how we solve for all the parts of this 30, 60, 90 triangle for both of them. All right, so here in this one, another part of the warm-up, find each measure. So RT here, RT is right here. This is an arc, so we're going to go from down here to up here. And so we're looking at what information do we already have. So if we start working through this diagram, we can see a variety of things. We can see that the top part of this is half the circle right here. And if that's half the circle, then we also know that we can subtract 180 or 126 from 180 to get the measure of RT. So when we do that, we get 54 degrees. So 180 minus 126, 54. So this down here was 54 degrees. Then it asks us for UQ. And UQ is a segment. And here, if we look at this, we have that this right here is 4. And this right here is 4. Which means we have two sides of a triangle. I don't know if y'all notice the triangle right here. Both of those are 4 and 4. And also, this is a right triangle. So if both of those are 4, then our hypotenuse would be 4 squared plus 4 squared, 16 plus 16. That would be 32. And remember, we got to take square root of that to get the answer. So the answer for UQ is going to be 4 square root of 2, because 16 times 2 is 32. So the objectives for the lesson today are to find the area of sectors and arc lengths. We're also going to find segments of a circle. So we're going to do all three of those things today. These are some of our vocab: sector of a circle, segment of a circle, and arc length. So the area of a sector is a fraction of the circle containing the sector. Just to define that, we're going to find the measure of the angle or the arc over 360. And then we're going to multiply that by the area of the circle. Now we all know that the area of a circle is pi r squared. That's what this is right here, pi r squared. And we're going to take the measure of the angle, either the arc here or the central angle, and we're going to put that over 360 to find it. Now on y'all's formula sheet, it has pi r squared theta over 360. So what I need you guys to understand is that that theta on the formula sheet has to do with the angle measure or the arc length, okay? And you need to remember that because that's true every time we have theta in any problems. Remember also that when you write degree symbol after the M in the formula, it helps you to remember that we're talking about degrees, not arc lengths, okay? So we're going to find the area of each sector here. So we're going to just populate our formula, pi r squared theta over 360. So I'm going to write that. And remember, m and theta are interchangeable. So I'm going to go ahead and use this formula right here. Pi r squared theta, let's just make this theta, so we know that that's what it is on our formula sheet, over 360. So we're going to plug that stuff in, and r is 12. Going to square that, multiply it times 131, and then divide it by 360. We're going to give our answers two ways. We're going to give our answers in terms of pi, and if you recall, that's our exact answer, and then we're going to multiply our answer by pi. All right, so let's look at the next example. So again, we're using our formula, pi r squared theta, because again, that's what's going to appear on your formula sheet, over 360. So our r is 5 this time, and our theta is 25. So we're going to plug those in. So we're going to do 5 squared times 25 divided by 360. Going to leave pi in our first answer, and then we're going to multiply by pi to get our second answer. And remember, don't round things from the first answer before you multiply by pi, because if you do that, you'll get the wrong answer. All right, do these two check it outs and then come back to me when you're done. Okay, so with this problem here, again, our radius is 1, our theta, keep doing that because that's what's on our formula sheet, y'all, is 90. So we're going to plug those into the formula. And then we're going to, again, give an answer with pi in it and an answer when we multiply by pi. Pause the video and do the second check it out example as well. All right, so here we go. Again, our radius is 16. And again, remember, this is our theta. That's our angle measure, or our arc length, either one. And then we're going to do 16 squared times 36 divided by 360, leave pi in one of our answers, and multiply by pi for our second answer. And oh yeah, don't forget that all of our units will be squared here because we're talking about area. So with the windshield wiper, when we talk about a windshield wiper blade, it's 18 inches long, and the area covered by the blade rotates through a 122-degree angle. So again, we've got our radius right here, and then we've got our theta right there. So here again, theta. So we're going to square 18, multiply that by 122, divide it by 360. This time we are going to multiply by pi though, because it wants to know to the nearest square inch what the answer is. So our next problem is to check it out. And you guys, if you got the notes, then this wasn't on the notes. So here it says to the nearest square foot, what is the area of the water in a sprinkler that rotates through a semicircle of 180 degrees and a diameter of 720. Here again, we need to look at what is our theta. So this is our theta right here. And then this is diameter. So we have to notice to get the radius, we got to divide that diameter by 2. So our radius is actually going to be 360. So again, we're going to plug these into the formula. Pi r squared theta over 360. That's going to give us 203,575 feet squared. Now, why again do we not give an answer in pi? Because in real life, we don't give answers in pi. We have to actually compute it by multiplying it by pi. All right, so now we're going to talk about a segment of a circle. It's a region bounded by the area, by an arc and a chord. So it's this little, you see this green area right here? It's this green area. So what we're going to do to find that is we're going to find the area of the sector first, and then we're going to find the area of that orange triangle, and we're going to subtract the area of the triangle from the area of the sector, and that's going to leave us with just that little green slice, okay? So we're going to talk about how to do that. So the first thing we have to do, again, is find the area of the sector. Now, we've done this a couple times, so you guys should be pretty good at this by now. So our radius here is 9. Our angle is 120. So we're going to, again, populate that into our formula. And and we're going to find the area of the sector. So the area of the sector is 84.82 centimeters squared. Now, we're going to multiply this by pi again, because if we're going to subtract the area of a triangle is not going to have pi in it. So we're going to go ahead and find that area, and then we are going to now find the area of the triangle. So I'm going to pull that triangle out and redraw it right here. So I put the 120 degrees up here where n was, and the 9 and the 9. So now what we have to do is we have to see if there's a way that we can solve this. Well, what I notice is if I bisect, I would draw this right here. I would bisect this angle. So that means this is 60 degrees and this is 60 degrees, which now we can see that this is a 30, 60, 90 triangle. So we're going to bisect angle L and M into two 60-degree angles. Now we have a 30, 60, 90 triangle. We actually have two of them. So now we got to find the height. So again, I recall that when I have a 30, 60, 90 triangle, the hypotenuse is equal to 2 times the short leg. And I know that this is my hypotenuse because it's opposite the right angle. So all I do to get that is divide that number by 4.5. So let me go ahead and erase this a little bit so you guys can see where we got the 4.5. So the 4.5 goes right here. This is our 4.5 as our height right there. Now we have to find the base of the triangle. So again, we're going to use that left triangle, and we have again a 30, 60, 90 triangle. So we know that the formula for the long leg is the short leg times the square root of 3, and we have now the short leg is 4.5. So that means that we're going to go ahead and do 4.5 radical 3 there, 4.5 radical 3 right there. We could do 2 times that. That gives us 9 radical 3. So now we do have the whole base, because again, this right down here is 9 radical 3. So if that's 9 radical 3, then we can multiply our base times our height and divide that by 2, or multiply it by 1/2, same thing. So that gives us 25 times the square root of 3. And that's going to give us 35.07. Now, what we're going to do with this triangle is we're going to subtract it, the area of the triangle, from the area of the sector. When we do that, it gives us just this part right here, which is what we were looking for all along. So what you guys need to remember is all of the tools that we've learned how to find sides of a triangle, those are the things you're going to use in this section. So that means you could use a squared plus b squared equals c squared. You could use a trigonometric ratio. You could use any one of those tools to find the base and the height of a triangle. All right, so now let's go ahead and go to this next problem. So this one says, again, find the segment. So we're looking for the green part here, segment of the sector. So this time, again, we're going to find the area of that piece of the pie, the sector RST. So we're going to do that first, and our radius again is 4, and our theta this time, this is our theta, remember, is 90, because that's a right angle in there. Hopefully all of y'all saw that. So we're going to compute this, and again, remember, we got to multiply by pi here. Now we're going to find the area of that triangle right there. So on the next slide, we're going to pull that triangle out again, and if you notice, this is RST right here. And both of these sides are 4, and this side right here is 4 as well, because it's another radius. So now we do have our base, and we have our height. So the formula for the triangle is 1/2 base times height, or base times height divided by 2. So half of 16, 4 times 4, is 8. So now again, what we're going to do is we're going to subtract the area of the sector and the area of the triangle. That gives us 4.57 meters squared. All right, so the last concept we're going to talk about today is we're going to find now arc length. And to find the arc length, it's really just a fraction of the circumference. Now, the circumference is the distance around the circle, if you recall. So if we're trying to measure from A to B, an actual measurement like with a tape measure, then we would find it by finding all of the circumference and then finding that measure of either that arc or that angle over 360. So that's exactly what we're doing here. Now again, on your formula sheet, it has theta right here where our measure of the angle degree is. So that's going to be theta on your formula sheet, and that's over on the left-hand column right above area. All right, so this time again, we're going to populate our formula. This time we're doing 2 pi times the radius times the angle measure over 360. And again, we're trying to find from here down to here, that actual length, when the radius is 8 centimeters and the arc is 134 degrees. So we're going to multiply 2 times 8 times 134, divide that by 360. Remember, always leave your pi for last, because again, here they're wanting us to give an answer with pi and an answer when we multiply by pi. Okay, let's see if y'all can do this problem. Pause the video and see if you can put it together for me. Okay, so come back to me. So now, again, we're using this formula. Remember, again, on the formula sheet, it's got theta there. So we're going to do 2 pi r times theta over 360. So we're going to multiply 2 times 2 times 62, divide all of that by 360, get our answer with pi. And remember, this time these are just meters, because again, this is just a length. This isn't an area. And then when we multiply 0.69 times pi, we get 2.16 meters. Here again, GH, 40 degrees. Our radius is 6. Go ahead and do this problem. All right, the last, check it out, 4B. Go ahead and pause the video, do it, and come back to me. Again, our radius is 4. Our theta is 135. Multiply 2 times 4 times 135, divide that by 360. That will give us our answer with pi, and then we multiply 3 times pi to get 9.42. Okay, so then we have these last 3. And so we could go ahead and solve these, but what I'm really more interested in is seeing if you guys know what formulas to use with these. So go ahead and pause the video. What I want you guys to do is write down the process that you do these 3 problems with, and then come back to me. Okay, on this one, so we're going to use the formula pi r squared theta over 360 to find this one. So number 2, because we're finding the area of the sector, and that's right off the formula sheet. Now, number 2, we're finding the area of the segment of the sector, so that's the red part. So on this one, we're going to do pi r squared theta over 360. And whatever that answer is, we're going to then subtract the area of this triangle from. So that's going to be base times height divided by 2. That then will give us our answer. Number 3 is arc length. So this is going to be 2 pi r theta over 360. Now again, if you don't know which formula to use when, then you're going to have issues in this unit.